video on graphing this logarithmic function, log base 3 of x, finding its inverse, and then graphing its inverse, and also finding the domain and range of each, both f of x and f inverse of x. So we would start here. We need to find some points. I know some easy values to put in for x here. Maybe I'll put in 1. It's always easy to take log base anything of 1. Or I could put in 3, maybe I could put 3 squared or 1 over 3. If I put in 1, anytime I put 1 into a logarithmic function, log base 3 of 1 is going to be 0, because I can write this as 3 to the 0. 3 to the 0 equals 1. 4 to the 0 equals 1. E to the 0 equals 1. So regardless of the base, I can write that 1 as the base to the 0 power. So log base anything of 1 is going to be 0. Now the next point, I'm putting in 3, log base 3 of 3. Well, 3 is just 3 to the 1. So log base 3, 3 to the 1, logarithm, exponent, they're inverses. So log base 3 of 3 to the 1 is just 1. Third point, maybe f of 1/3. That's 3 to the negative 1 here. And that's going to be just negative 1. So I get these points. Let me shrink this down. I get these points 1, 0, 3, 1, and then 1/3, negative 1. And those are the points I'm going to use over here on my graph. 1, 0, 3, 1. And then 1/3, negative 1 right here. Now logarithms, they curve downward, so they're growing less and less, but also when we talked about logarithms initially, we said that it doesn't make sense to take the logarithm of a negative number. I can't, 3 to the anything, it's never going to be a negative number, so it doesn't make sense for me to put a negative number into this logarithm here. So for that reason, the logarithm's undefined over here, and there's a vertical asymptote at x equals 0 where the logarithm starts to be undefined. So this graph just dives down towards that asymptote and doesn't exist anywhere else. Vertical asymptote again is x equals 0. That's what you expect for logarithmic functions in general, unless there's some sort of shift going on. So now finding the inverse. If I want to find the inverse, I start by switching x and y. So I'll have x equals log base 3 of y, and then I need to solve for that y value. Now to solve for it, I know that the logarithm and the exponent are inverses. So if I take 3 to the log base 3 of something, I should just be able to get that something out. So not e. 3 to the x is what I'll have on the left side, and then I'll have 3 to the log base 3 of y on the right side, but this right side is just y. 3 to the log base 3 of y is just y. So my inverse function is 3 to the x equals y, or y equals 3 to the x. Now to graph it, I could go through and find points, but I could also just use the points I already have and flip them. 1, 0 becomes 0, 1. 3, 1 becomes 1, 3. 1/3, negative 1 becomes negative 1, 1/3. Previously I had a vertical asymptote, now I have a horizontal asymptote, y equals 0. And then the exponential function will approach that horizontal asymptote. And so I notice that I have nice symmetry here. These could be reflected over the line y equals x there, and they'd be related. I also want to find the domain of these functions. The domain of the logarithm, we said it's always positive, the argument, which you put into the log. So we could say that's 0 to infinity, or maybe the set of x such that x is greater than 0. The range here, though, goes all the way from negative infinity up to positive infinity. It's all real numbers. For the inverse, those get swapped around. What was the domain is now the range. What was the range is now the domain. So the domain of the inverse is all real numbers. It's an exponent, so that's or an exponential function. That's what we'd expect. The range, on the other hand, is going to be 0 to infinity, since that exponential function stays positive. Set of x such that x is greater than 0. Okay. I hope this helps. Bye.